So in the last few videos, we talked about how to start the database design. So we talked about how you start by going to the users and getting an idea of what it is they want to store, what are the reports that they want to run on the data. And so you start with the external view, and then you go down to the conceptual view, the logical view, and the physical view. One of the other things that needs to be done is choosing the appropriate database management system. So database management systems are not all the same. They vary depending on the data model, how the data is modeled and the data is stored, the users that will be using the database, how many users, and whether the database is distributed or not. So these are a few criteria that differentiate the database management systems, and we're going to talk about each one of these. So here's a video that you can watch for extra information. But basically, when we talk about data model, there are three categories. So there's the traditional data model. It can be hierarchical or network. And then there's the relational data model, and the relational data model is the one that we are going to be using in this course. It's the most popular model right now. And then there's the object-oriented data model, which is the newest type coming out. So let's start by looking at the hierarchical data model. The hierarchical data model structures the data in such a way that you have a top-down structure. You have something that is the root, and everything comes out of this root. So every table, except for the root table, has some kind of parent. So if I think of MCC as a college, I can break up this college into some infrastructures and some departments. And then I go to the department and I break up the department into course and teachers and students. So every department contains some teachers that are teaching, some students in that department, and some course. And then I can further break down every one of these entities. So as here, the college is related to the department and infrastructure. The department is related to the course, teacher, and students, but you see that there is no relationship between students and infrastructure, or a course and infrastructure, or a course and a teacher. So not all relationships that exist can be represented using a hierarchical data model, and that's why it's not heavily used right now. So if you think of a course here only belongs to one department. I can't have a course that's shared between two departments. So for example, if I have like the Python course, I can't share this Python course between the computer science and the computer networking if computer science and computer networking are not in the same department. So there is a limitation on the relationships that can be represented. We say one-to-one relationships are supported, but many-to-many relationships are not supported. You cannot have a teacher that belongs to more than one department, for example. And so this is the limitation with the hierarchical data model. It's not very flexible. The next type of data model, another traditional data model that was used frequently, was the network data model. And this was nice in that it solved the problem of having only one-to-one relationships. So with the network data model, you have like all these entities, and any entity can be related to any entity. Many-to-many relationships are possible. You're not limited to one child, every child having one parent. In the network data model, each child can have more than one parent. Now, these two have kind of gone away, and the common data model right now is the relational data model, which allows links between any two tables, regardless of where they are in the hierarchy. So you can have one-to-one relationships, you can have many-to-many relationships, you can have one-to-many. You don't need a root node like you did in the hierarchical hierarchical model. So this is the model that we are going to be using. It's two-dimensional. That means we represent data in a table. Two-dimensional means it has two dimensions. We have rows and we have columns. And the newest data model that's coming out now is an object-oriented data model, which means it's three-dimensional. What does that mean? It means we have rows and we have columns, but instead of a column just storing one piece of information, a column can now store more than one piece of information. So one of the limitations that we're going to see when we start developing things in the relational data model is that when you have data that you are storing, so for example, here we have some students, their names and their age, and then these students are going to be enrolled in some courses. So here I have this, the first table is a list of my students. The second table is a list of my courses and who's teaching each course. And now I want to be enrolled in more courses. So student 1 is taking Java and they're also taking C++. Now in a relational data model, I cannot store this like as this table. I can't say that student 1 is 1, subjects 1 and 2, because every one of these values just needs to be one item. It can't have one. So we will see that in the relational data model, we will need to have a table like this one where for every subject a student is taking, we're saving it and we're storing it in a separate row. Okay, so this is the relational data model, how we're going to be doing it in this course. Now the object-oriented data model gives us the flexibility where I can store more than one value inside a cell. And so this is the new model that is starting to being adapted with the new databases, the database management systems. And so it allows us for storing complex objects. Now it is not good at accessing a group of items, because now if you want to get like a single subject, you want to do a filter on a subject, you kind of have to go to this column. You can't say if the column is equal to Java. You have to say, you know, contains Java. So it makes it a little bit more complex when you're accessing. That makes the select statements a little bit more complex and running reports more complex. And that's why it hasn't taken over relational databases totally yet, but it's moving, the industry is moving towards object-oriented data models. But for now, for this course, we're going to be following the relational data model, and we'll talk more about it as we learn how to do things. So that's the first way of classifying databases. What data model does it follow? Is it hierarchical? Is it network? Is it relational? Or is it object-oriented? Another way to classify database management systems is based on how many users are going to be using it. So if you have a database that's going to only be used by one person, you know, one person is going to be maintaining this database and using it, then you are talking about a single user database system. Only one user is going to be using it at any time. You don't have to worry about more than one user using it at any given time. And so that makes the database simple, because you're only dealing with one user. Now, most of the databases, you know, if you think of Amazon or MCC, the databases are not going to be single user. A single user database might be like a doctor's office, where we have a database that's maintaining the records of the patients and the doctors and maybe the staff and the appointments. Maybe that would be a single user database. But most big companies and institutions probably need a multi-user database. And so you will need to deal with issues, and not you, but the database management system needs to deal with issues that support multiple users concurrently using the system. So if you have one user using the system at the same time, you need to make sure that you have a database. So you need a multi-user system. And usually those databases handle large amounts of data. So that would be another thing to take into consideration, how many people are going to be using this database. The is a database distribution, whether it's distributed or not distributed in different types. And this is very important. So there are 4 distribution systems. So there's centralized systems, distributed systems, homogeneous distributed, and heterogeneous distributed. So actually homogeneous and heterogeneous come under distributed systems. So when we talk about a centralized system, that means that the central database, the database management system, is stored at a single site. It's at a central place. And so you have the database, and if you want this database to be accessed via like at different sites, like, you know, let's say these are the students and this is MCC where we're storing the student information, but maybe we want Capital and Asdentech to have access to our student information in case a student goes and registers there. So in that case, we have the database stored at a central place, and that central place is usually the main site that is using the database, the main site that will be accessing the database to store information and get reports. But you have it available also for other sites if they need it via network. Can you think of any disadvantages? Well, number one, the centralized system is a single user because you have one site that is responsible for the database. Now, if the site here that the database is stored on, so let's say this is the computer the database is stored on at MCC, if that site goes down, no one can access the data. Okay, so this computer now is off network. None of the other computers can access the data. So this is a disadvantage. So anytime you simplify things, you know, simplicity has a cost. And here the cost is that, you know, we can't access the data if this computer goes down. Now, also, you're accessing the information via a network, so that might be a little bit slow and it might be expensive. So you have a bottleneck here. The network is a bottleneck, how you're going to access the information. So that was the centralized system where you have it in one place. Another option is a distributed system. A distributed system means that the database, the actual database, and the software are replicated. We say distributed. What that means, it's replicated or fragmented, broken down from various sites that are connected to connected via the computer network. So now you have this database and it's replicated. So whatever you have here at site 3 is also available at site 2, at site 1, and at site 4. You have the same information replicated in different sites. Okay, so advantages, it solves the problem of a single user. Now you have all these different sites and every site can access the database at their own place, so you don't need the network bandwidth. Okay, so it's a little faster because the database is right there at the site. Every site has a copy of the database, so every site can access the database immediately, and they can all access it at the same time, which is good. Okay, if one of the databases goes down, that's okay. These other databases can still be accessed because you have the data duplicated. However, that also comes with disadvantages. Can you think of any disadvantages? The main disadvantage of the replicated system, distributed system, is that you need to synchronize all the database, all the data in the database at the end of the day. So if site 1 adds, 10 students, site 2 deletes some courses, site 3 does something, at the end of the day, you need to capture all the changes that were made to all of the databases and modify them. So you have to go to every site and add the new students, and go to every site and delete the courses. So every database now needs to be synchronized at the end of the day, and that might not be very easy to do sometimes. When we have distributed database systems, there are two types. One of them is homogeneous distributed database systems. I want you to think back to when you took chemistry and think of a homogeneous solution versus a heterogeneous solution. So a homogeneous solution is one where you kind of stir and at the end everything dissolves and you feel like it's just one soluble solution. So a homogeneous distributed database system is one where everything kind of seems like it's one thing. Basically, all the sites have the same operating system. So yes, you are replicating the database in multiple sites, but the system is running on the same, all the systems are running on the same operating system. Why is this important? Because it makes the exchange of the data between the sites easier when all of them are the same OS and same vendors. When everyone is running the same operating system, everyone is running the same database, vendor, all of them are running Oracle, or all of them are running Postgres, it makes things easier. Now, sometimes that's not possible because different buildings and different parts started out with different operating systems. And so in that case, the database, we say, even though it's distributed, we say it's a heterogeneous distributed database system. It is not the same. Not all the sites are running the same software. Not all the sites are running the same operating system. And so in addition, you know, when we talk about distributed database systems having to be synchronized at the end of the day, you need additional software to make sure that you can support the migration and exchange of data between these two sites. They're not all using the same software. So this is the end of the chapter. For today's class, there is no additional classwork. And for the chapter, it's available, the homework for it is available on Blackboard, and it is due 1 week from today.